this is 2.4, and the title is Circle Graphs, although I was informed that they are actually called pie charts.
Pie charts.
Correct? Okay, so pie charts, so I have to say it like that too. Pie charts. That makes it better. Okay. Makes it more fun, right?
Yes.
Okay. No, there's a head shake over there, and there's a definite yes over there. Okay. No. Okay, new skills. Working with pie charts. A circle graph or a pie chart is used to display how a whole is divided. Now, not a hole in the ground, but a one complete whole 100% thing. So something that's full, 100%. So how something is divided up, right? The sectors of the circle graph represent parts of the data. So here's the example that we're going to go through. We're going to spend some time going through this right here. So the following circle graph or pie chart shows how people in Maxine's office building get to work. There are 350 people working in the building. 350. Okay, so that's good to know. 350. Now notice that in the pie chart, it's starting to fade. The pie chart starting to fade. Pie chart. Okay, so notice that on the pie chart, the circle graph, these are percentages. They're not numbers, right? They're not a number of people. So we kind of have to do some figuring if we want to figure out, how many people, for example, walk. So here's the walk, right? That black part. So we know that 3% of people walk. Now it's the reason why pie charts are in percents is because the whole chart, the whole circle is 100% of everything that's being considered, right? And so if we have exactly half of the circle, that would be 50%. This part right here that we see is a little bit more than half, and it's actually 61% of the entire area of the circle. All right, so let's answer a few simple questions here. What percentage of people walk to work? Well, we just identified that, didn't we? That's the black one. So the percentage is 3%, right? 3%. What percentage of people come to work in a car? So what we do is we look over to the right here, and we look at where car, okay, is, and we look at this color, and we try and match that up with the pie chart, or the pie chart. And so, of course, I messed that one up already by doing the blue stripes, but you see how this is this one right here, okay? So it's 61%. Now it says what percentage of people? 61%. We get that right from the graph. Everybody good with that? That's pretty straightforward? Pretty easy, right? Okay. So the second part is how many people is this? So now we have to convert this percent into a number of people. And so we know we have a total of 350. So guess what? This whole thing, everybody represented here, is 350 people. How do I find 61% of 350 people? So how? Not the answer. How do we find that? What do we do? Go ahead.
Could you change the percentage into like a decimal and then divide it by 350?
Okay, so change this. You said change this into a decimal. I like that. 0.61, right? Because if it's out of 100, you move the decimal place back 2 spaces, and that's the decimal form. And then you said divide it by 350.
No, yeah.
So this number divided by 350 is what you said?
Yeah.
Okay, what does that give you for a number if you do that on your calculator?
I don't know,
49.1? I'm not even sure if that would be 49.1. That would be probably a few more decimal places. So, okay, so that's not what you do actually. Good try.
I've got to put the 5.
Okay. Okay.
Is he 573?
Okay. So what we do is we don't divide. Okay. We don't divide. We actually multiply this number by the total number of students here, or people. So we do the decimal form of the percent times the number of people. So what is 0.61 times 350? Is it 230? Everybody else get that?
231. No, 213.5.
Okay, 213.5? Did someone say? Okay, I will do this on my calculator up here. Let's just see. So 0.61 times 350 equals Okay, 213.5. So obviously we can't have 0.5 of a person, right? So that's an approximate percent. We didn't have the point, the decimal form there. It's not very exact. So we have to. Are we going to round up or round down? Do you think? Yeah, let's round up. If we have 5 or more, let's round up to the nearest person. So that's 214 people. That's the best guess that we can make for this question B. Okay, so what percentage? Oh, and I crossed out the 61%. That's part of the answer. Okay, 61%. And that's 214 people. So the decimal form of the percent and multiply it by the number. Okay? All right, so the C says, consider those who carpool, walk, or bike. Is this more than the number of people who take public transit? That's a good question. So carpool, where's carpool? That's this one here. It looks like 9%. Okay, so I'm going to write that down right there. Carpool, walk, or bike. So walk is, we said 3%. So let's add all those up. Carpool and bike is this one, 5%. So that's all the people that carpool, bike, or walk. So what is that? 9 and 3 is 12, plus 5 is, that's 17%. Okay? Right with me there? So is this more or less than the number of people who take public transit? So here's public transit, which is this one here, right? That's 22%. So this 17 is less than 22%. So we would say less. It's less than. Okay? Less than. And then how many more or less? So you'd find the difference between 22 and 17. So you go 22% minus 17%. So that's how many more. Now, does it say? Consider those. Okay, well, we could find out the percent first. It looks like they might be looking for the actual number of people here. And I know the solutions are on there, but I'm trying to work this out without us looking at the solutions too much. So what's the difference between 17 and 22? That's 5%. Okay. So what's 5% of 350? Well, what's the decimal form of 5%? It's 0.05 times 350. What's that going to equal? 17.5? So let's say 18 people. Okay? So for C, it's less than, okay, that grouping is less than public transit. And by how many more or less? Well, let's move that into people, from percentage to people, and we'll say that as well. Okay, so less than, and 5% difference, which is 18 people. Okay, you okay with that? You guys understand how to get from one to the other there? So here are the solutions down there. Okay, now they went to 17. Did you say it was 17.5?
Yeah.
Okay.
Also,
they did the percentages earlier. They found the percentages first, and then rounded and did the differences. So if you did it that way and got 18, I would be totally fine with that.
and for B, on the example, they use car and
Okay, so good. One note as well. We went back and looked at this question a little more carefully. What percentage of people come to work in a car? So we're not talking about just this group right here. We're talking about in a car, which would include carpooling as well. So thank you for noting that. So that would be 61%, and plus the carpooling people, which would be 9%. So what is that total percent then for B?
7.
Yeah, that would be 61 plus 9, or 70%. Good. Yeah. So that would be car and carpool for B. Awesome. Okay, good. Any other questions? Is that understandable? Okay. So, I think now would be a good time for you guys to work on the build your skills. There's your time to practice. Here is a pie chart that you guys can work with here. Okay, go.
Okay, white and black are not common.
So for number 2, the question was, B says, if he puts $250 per month into savings, what's his total income? So we're assuming that this represents all of the money that he makes, and that he does, whoops, this one right here, And this is what he spends it on. Okay? And so the 100% would be his total income. And so if $250 is 10%, what is 100%? That makes sense? So there's different ways you could write this. You could say $250 is to 10% just the same as X amount of dollars, because we don't know what the total is to 100%. Okay? Now that's a simple proportion. We know that $250 is 10%. So what amount of money is the 100?
Like the 100%. 100% is 1.
Sorry?
The 100% move it to, would that just be 1?
Well, yeah, if you're doing decimals, if you want to do the decimals, then you could write like this: 250 over 0.10 equals X over 1.00. Yep.
29.
So what do you get? You cross multiply and you divide, and you should get X equals what? 2,500. 2,500. That's correct. Okay? Or if 250 is 10%, the whole amount, the 100%, is 10 times that. Right? So 10% times 10 is 100%, so you could just do times 10 as well. You could do times 10 down here to get that, and then you'd have to do times 10 here to get this one. So either way you get it, that's what they mean by that one. Okay? Good question.